And what you want to look at and on the front of the foldable, of course, when we are multiplying, we multiply like we normally do. Rad, whatever number under here, we call it A, multiplied by rad B. You just multiply the two numbers together. And of course, after you do that, you will simplify it like you did on your quiz. So, if you come out with rad 20, you would have to break it down into factors. You'll also have some radicals you're multiplying with exponents. So we know when we multiply with exponents, we actually add them. So that's why you see m to the first and m to the second equals m to the third. Okay, of course, 5 times 3 underneath is 15. And of course, you add your exponents for your n's. You only have n to the second, so that stays there. And you also multiply your outside numbers. So 2 times 4 is 8. And then, of course, just like this is what you were given on the quiz, and then you just simplify it to the last answer that you see here. When you're dividing, we can divide just like we normally do with numbers. So sometimes you'll see the radical over the entire fraction like this, which really means the same as this. So when you see it over the entire fraction like just a long radical, it really means you're taking each one individually. Okay, but this is just a shortcut way of writing it. So that's why you see it written that way. You can and you should simplify just like you do a fraction, like 8 over 50 can be reduced to 4 over 25. When we divide with exponents, we subtract them. So that's why you see that became an x to the second. Okay. In this case, everything comes out to be perfect. 4 is perfect, x squared is perfect, 25 is perfect. So you take everything outside of the radical by taking the square root. Okay. Any questions so far on that? Just the top part? Okay, give me 1 second. Example. So example number 1. Okay. So in example number 1, we're just going to multiply and get rad. What's 6 times 8? 48. And then you want to simplify it just like we just did in our last section. So we're going to say 16 times 3. And then, of course, you take the square root of 16 out, and that leaves you 4 rad 3. So like I said, the first part of this lesson, you guys, we made a second part because first part we're just multiplying. Second part we're simplifying, which you already know how to do. All right, let's take a look here. So we're going to multiply our outside numbers. So 2 times -4 gives us -8. Then we multiply our inside numbers. 15 times 20 will give us 300. And then, of course, we can break the 300 down to a perfect square of 100 times 3. Okay, so when we take the square root of 100 out, what does that give us? 10. 10 times -8 will give us -80 rad 3. Okay. All right, let's look at question number 3. Okay, this one just happens to have some variables in it as well. So we're going to do 3 times 24, which is 72. We're going to add our exponents. We get x to the third. And then we can break down the 72. The largest perfect square in 72 is 36 times 2. And then we're going to break down that x to the third to factors of x squared times x. Take everything out that is a perfect square. So the square root of 36 is 6. Square root of x squared is x. And then we're left with rad 2x. All right. Number 4. So same, now here, instead of me multiplying 12 and 18, I'm going to do this one a little differently because you're going to get a bigger radicand. So let's break down each radicand individually. So I'm going to take this 12b and I'm going to make this 3 times 4. Now, can you? Yes, but I want to show you an alternate way of working these when both of them have factors in it. So then I'm going to take the, and I'm going to go ahead and finish this. So this will give me 2 rad 3b. All right. Now I'm going to break down the 18b to 9 and 2. Okay. And then we take the square root of 9 out, which is 3 and 2b. So now I can still multiply, okay, because all I did was just simplify the radicands first. So I'm going to have 2 times 3 gives me 6 on the outside. 2 times 3 on the inside gives me 6, and b times b gives me b squared. Okay, now b squared is the only thing that's perfect, so I'm just going to take that out. So that'll give me 6b rad 6. Okay. So for dividing, what you want to do, if you can reduce, that's the first thing you want to look at. We cannot reduce rad 15 over rad 4. So we're just going to go ahead and say, okay, well, 4 is a perfect square. What is the square root of 4? 2. Okay, so your answer is just rad 15 over 2. It's not anything else you can do with that. Okay, that's it. You can't break down 15 into perfect squares as factors, so you simplify that as far as it can go. All right, let's take a look at number 6. Now, in number 6, you can reduce the 20 and the 45. Okay, so let's go ahead and simplify the 20. So I'm going to break that down to 4 times 5 at the top. And then I'm going to take the 45 and make it 9 times 5. Okay. So when I simplify the top, I'm going to end up with what? 2 rad 5. And at the bottom, take the square root of 9 out, which is 3. So I end up with 12 rad 5. All right, now this is going to be a different process because we have a radical in the denominator. So one thing you need to remember, you cannot, and please write this down somewhere, okay, you cannot leave radicals in denominator. All right, so since you cannot leave radicals in the denominator, we do a process that's called rationalizing the denominator. So what we're going to do by what we mean is we want to have a rational number. Right now, rad 5 is not a rational number. So we call it rationalizing the denominator. We have to have a whole number down there in the denominator. So in order to do that, we multiply the radical times itself. Because when you multiply a radical times itself, it ends up being a perfect square. Okay? Think about what I just said. When you multiply a radical times itself, like if I multiply rad 3 times rad 3, that's rad 9, which is 3. So it ends up being a perfect square when you multiply a radical times itself. So what we're going to do is multiply, and of course, just like when you normally do with fractions, if you multiply the denominator by a number, you also have to multiply the numerator. So we're going to say, okay, I need to get rid of this rad 5. I'm going to multiply the top and bottom by rad 5. Okay, you have to do the same thing to the top to make it like one whole, because then you're not changing the value of the problem. Okay, now after you do that, because I already said this just makes that a perfect square. Is that correct?
Yes.
Okay, here we go. All right, so now, so what I'm going to have left at the bottom is really 12 times 5. And what's 12 times 5 at the bottom? 60. Okay, and then of course at the top, what am I going to have? 10. Very good. And then we can just reduce that. We have no radicals. Actually, it doesn't matter. You can have radicals left in your numerator. You just cannot have them in the denominator. Okay, but so if I had, 2 rad 10, that would have been fine. Okay, but it actually comes out to be 10. And then we can reduce 10 over 60 just like you normally would a fraction, and that equals to what? 1 over 6. That's the final answer. So always put everything in simplest form, even if, you come out with a fraction like this. Now, what you could have done as well, and let me just show you this because I want you to see, we could have taken this a little bit easier. Let me move this over. And right here, let me just erase this so you can see a little shorter way. Yeah, we could have, in this case, probably just crossed these out. Since I had 1 at the top and bottom, and then you would have had 2/12, which is 1/6. Now, that's not going to always happen like that. So, because you need to know how to rationalize the denominator. So we're going to be adding probably about 3 or 4 problems at the bottom of this foldable, so you can have some additional examples. They don't always work out that perfectly, okay? All right, let's move on to this one here. Now, this one actually comes out to be a perfect square already, so I can just change this to what at the bottom? 8. Very good, because the square root of 4 is 2. 2 times 4 is 8. Okay, this one works out nicely at the top because 16 is perfect. Square root of 16 is what? 4. 4 times 3 is... Did somebody say 5? Okay. All right. And then we can reduce 12 over 8 to what? 3 over 2. And just leave them as improper fractions. You don't need to change them to mixed numbers. All right, so these are great too because they're coming out to be perfect squares. And that's why I want to give you some additional examples at the end where this is not a perfect situation. All right, so square root of 4, 16 is 4. 4 times 4 gives us 16. And then square root of 25 is 5. 5 times 4 is 20. And then we can reduce that to 5 over 4. All right, so this is where you're going to add some additional problems. So for number 9, we're going to call it number 9. So let's write, actually, rad 5 at the top over rad 2. So now we don't have that perfect situation where you have all these perfect squares. But I know this is not in simplest form because rad 2 is an irrational number. So I have to rationalize the denominator. I can't have that left in my denominator. So like we did before, we're going to multiply the top and bottom by rad 2 because that makes the denominator a perfect square. So rad 2 times rad 2 gives me the square root of 4, which is what? 2. And then when I multiply rad 5 times rad 2, that gives me rad 10. Now I cannot simplify that because one number is under the radical and one is not, so that is my final answer. Okay. All right, let's add a 10. And we're going to do rad 3 over rad 6. So I'm going to multiply. I'm going to rationalize the denominator and say rad 6 over rad 6. So at the bottom, I'm just left with the square root of 36, which is 6. So again, that's my whole point, is to get rid of the radical in the denominator. When I multiply my numerators, that's going to give me rad 18. Now, 18 is not in simplest form, correct? Okay, how can I break down the 18? 9 and 2, just like you did on your quiz. Okay, what's the square root of 9? Take that out, 3 rad 2 over 6. And then I can reduce these because both of them are outside of the radical. So my final answer would be rad 2 over 2. Because you're going to reduce 3 over 6 to 1/2. You don't need the invisible 1. Okay. All right, so I'm going to have you try this one on your own, and then we're going to call this number 11. It's going to be rad 3 over 4 rad 18. Okay, try that and see what you come up with. So here's the process right here. You should have rad 6 over 24. And you cannot reduce that. So what I did first was I took the 18 and I took it to 9 times 2. Took the square root of 9 out, which is 3. Multiplied it by the 4, and I got 12 rad 2. Okay, I can't leave the rad 2 here, so I multiplied by rad 2. 3 times 2 is 6. Take the square root of 4, which is 2, multiply it by the 12, and you get 24. Okay, any questions?